A very good morning and a warm welcome to day 3 and final day of the 8th National Conference of Ocean Society of India, OSICON 2023. It is my honor to welcome Sri Pattabhi Rao, the convener of OSICON 23 and Group Director in MoES, to deliver the welcome address and introduce the speaker.
A very good morning to you all. It's with great pleasure that I welcome you all to the third day of OSICON 23. Over the past 2 days, we have conducted 4 plenary sessions, 27 technical sessions covering 12 different sub-themes of the conference. We had full house sessions in spite of extended hours. We also had a wonderful cultural program by our colleagues on the first day evening and the award session in the second day evening. The journey so far has been truly inspiring. We witnessed several research findings, incredible exchange of ideas and discussions. Our commitment to advancing scientific knowledge has been evident in every presentation, every conversation, and every connection that we made. Today, we step into the third day of the conference to dive even deeper into the realms of discovery, collaboration, and knowledge sharing. I encourage you to carry forward the same enthusiasm and curiosity. We have discussed several research findings from the Indian Ocean, Pacific Ocean, and Atlantic Ocean for the last 2 days, and today we are going to touch the polar regions too. Dr. Thamban Meloth, Director, NCPOR, is here with us today to chair the session on polar sciences and cryosphere studies. Welcome, Dr. Thamban. Before we embark on today's scientific journey, we would like to start today's plenary session with an invited talk by an eminent space technologists and scientists. It's my privilege to introduce today's plenary speaker, Dr. Premchand Goel, former Secretary, Ministry of Earth Sciences. Welcome you, sir, to the OSICON 23. Dr. Premshankar Goel did BE in Electrical Engineering from University of Jodhpur, ME in Applied Electronics and Servo Mechanism from Indian Institute of Science, Bangalore, and PhD from Bangalore University. Dr. Goel is an Indian space scientist and technologist. He started his career by joining the Indian Space Research Organization in the project for Satellite Altitude Control System for spinning RS-1 satellite, and later joined the Aryabhatta satellite team. He served ISRO in different capacities and contributed significantly to the mission planning for remote sensing, communication, and scientific missions. Dr. Goel was chairman of Spacecraft System Advisory Board for IRS-1, project engineer for AOCS for Apple, and associate project director in SAT-2. He was the head of Control System Division, group director is AOCS, deputy director mission and control area, associate director of ISRO Satellite Center called ISAC, and was the director of ISAC from 1997 to 2005, and also the Space Commission. Dr. Goel was appointed as secretary the Department of Ocean Development in 2005 and transformed it into Ministry of Earth Sciences by integrating ocean, atmosphere, geoscience, and technologies to address the problems of the Earth in a holistic way. He was the first chairman of Earth Commission. He oversaw commissioning of Tsunami Warning System of India, initiated the modernization of Indian Meteorological Department, and pursued exploration of deep oceans. He has been associated with us in Deep Ocean Mission launched by Government of India. Dr. Goel was chairman of the Recruitment and Assessment Center of Defense Research and Development Organization, DRDO, and member of National Security Advisory Board. Goel has more than 100 scientific papers to his credit, published in peer-reviewed journal, national and international. Dr. Goel is an elected fellow of the Indian National Science Academy, National Academy of Sciences, the Academy of Sciences for the Developing World, Aeronautical Society of India, and the Indian Academy of Sciences. He is also an honorary fellow of Electrochemical Society of India and the Indian Institute of Technology, Mumbai. Dr. Goel has received several awards, and few of them include the Special Achievement Award in 1975 for Aryabhatta project and Hari Om Ashram Pandit, and also Dr. Vikram Sarabhai Research Award in 1983. In 1992, he was awarded ASI Lifetime Achievement Award by Aeronautical Society of India. The same year, he received WiseFic Industrial Research Award, followed by Om Prakash Basin Award in 1995. The Government of India awarded him with the 4th highest Indian civilian award, Padma Shri, in 2001. He is also a recipient of ISRO Distinguished Scientist Award. Sir, we missed you here in the inaugural session as you were engaged with the Chandrayaan mission at Control Center. We watched you on live telecast where we had the break session. That time we played this live telecast of Chandrayaan. Congratulations to Team ISRO on this remarkable achievement. Well done, ISRO, and looking forward for many more such remarkable achievements in exploring the other planets too. We are fortunate to have you here with us, sir, today, and eagerly waiting to listen to you on the genesis of Ministry of Earth Sciences in the talk, Well Done MoES, but there is a long way to go. Without wasting much time, I request you to deliver the talk, sir. Thank you.
Dr. Srinivas Kumar, Director in MoES, all senior people in the so-called earth science or ocean fraternity, lot of students, nice to be with the students, I feel young. When Dr. Srinivas Kumar called me for this meeting here, I mean, just to talk to you. So I just was wondering, what should I talk? I'm not really an ocean man in that sense. I've learned ocean only by asking questions to the people who are experts. So I've never read a book on ocean. So I thought I'll do something different. So thought came to me that, in fact, after I left 2008 MoES, I never had an occasion to talk to the people about how this all started, how the Ministry for Science got into existence. But before I go further, I just thought of sharing a thought with you. Anything that something path-breaking or new happens, and if it happens successfully, then there are 3 orders of, you can say, layers of people who do that. The number one is there has to be a visionary. Someone who visualizes, oh, we need such a thing. The next level is sometimes some person can be bold, but a next layer who will believe in that vision and they start creating a system, how that vision will be realized. And the third layer is there have to be set of people, sometimes hundreds, sometimes thousands, sometimes even tens of thousands, who not only believe in their vision, but work for it. Now, whether it is a thought of atomic energy, which was a vision of Homi Bhabha, and a person like Professor Setna, he actually implemented this system in place, and there are a lot of people who really worked later. And when you come to space, it was a vision of Sarabhai. And let me tell you, that today's ISRO is not Sarabhai's ISRO. It's a Post Dhawan's ISRO. Because Post Dhawan believed in that vision after the death of Sarabhai, and he created this system what is called ISRO. So it's a system created by Post Dhawan. And then there are thousands of other people like me who really worked our system. That's why ISRO exists today. You can take any organization, any successful. For example, take Infosys. It was vision of Narayan Murthy, but then he was joined 5 of his another friends like Gopal Krishna and Nilkarni, who really put the system in place. And then it became an organization which employs today more than 1 lakh people. So any system that you see, there are 3-level people. So obviously there have to be that 3 level here in this case also. Now, when you look at the background of the earth sciences, basically the immediate thing comes into mind is that there are a lot of disasters created by atmosphere. There are a lot of things happen in the ocean that bring disasters to the people, including tsunami and all that. Global warming is happening, and that was known for at least now 40 years. The thought started from a British scientist, and when he started this thinking first, global warming was very hard to sell this idea. But now everyone believes, except I think the president, past president of the United States, Trump. Otherwise, everyone accepts that. Then some people in India and elsewhere realize that we cannot study or understand ocean or atmosphere in isolation. Now that thought in India is not very old. And till I can say 2005, the ocean and atmosphere, they were hardly talking to each other. In fact, if you look at the reality, even the atmospheric people, they were not talking to each other. And I can say from my personal knowledge that the NCMRWF, which is supposed to be working on numerical modeling at that time, there was absolutely zero communication with the IMD, who was not ready to take the numerical modeling at all. In fact, when I had a first meeting with the IMD and I told them that, look, you have to start working on numerical modeling, the director, DG of that time, he said, no, sir, it's impossible. We'll never adopt numerical modeling. So that's happened in 2005. So under that circumstances, I don't know how many of you know Professor Narasimha, Rodam Narasimha. Those who have not heard, raise hands. All of you know? Oh, I'm happy that so many people have heard this name. He was basically aerodynamics person. In fact, not even aerodynamics, he was fluid dynamics person. His basic core expertise was fluid dynamics. A very well known researcher in the country and internationally. And in 2005, somewhere in April, I was director of ISRO Satellite Center. He came to me and he said, you will be offered Secretary of DOD, Department of Ocean Development, and please accept it. Well, there's some background. Some people had talked to me earlier, but he's coming to me and talking to that I will be offered by the government and I should not refuse it. So I asked him, sir, why? I had very high respect for me because he was interacting with us in ISRO. I asked him why. And then he, for next 15, 20 minutes, he explained to me that we want to create a Ministry of Earth Science, integrating these, and we need you for that. So it is a kind of a convincing he did to me. And that's the reason, really, I had never thought of in my life, because started space in 1970. So for those 1972 to 35 years, I never thought that I'll do anything else other than space. But then it happened. So idea was actually that we must take a holistic approach of creating a body that actually integrates. So how this happened now? Also, another thing happened. He not only convinced me, he convinced Professor C.N.R. Rao. C.N.R. Rao was he is a very well-known scientist who has developed more than 5,000 papers in chemistry. And he was a chairman of the body called Scientific Advisory Committee to the Prime Minister, SAC-PM. And in that process, Professor C.N.R. Rao, being a loyalist of Gandhi family, from Rajiv Gandhi's time, he had a very good connect with the government that time, particularly Mrs. Gandhi and Prime Minister Manmohan Singh. So that helped. He also convinced the government to that level that we need this. And after taking charge of the department of 1st July 2005, my immediate task was to create this Ministry of Earth Science. So the concept was articulated to many people. And when it was told to the cabinet secretary, that time we had Mr. B.K. Chaturvedi, he was the cabinet secretary. And he said, the concept looks good, but then how do you achieve it? There is no integration in one department itself, and you are now trying to bring from the DST the units into the Ministry of Earth Science. Our total strength of Ocean Development Department was not even 200. Well, this IMD alone was 6,000. So how do you integrate such a big system, and not only IMD, IITM, and CMRWF and all that, you have to create a system. And the also issue was, what is kind of a integration with respect to the earth science? Now, there were a lot of, I'm not going to get into the details on each aspect, but one thing was very clear, that we have to convince all the service departments. Service means whom we are serving. And serving was largely India Maritime Department. In some form or the other, whether it's agriculture department, whether it's mining, mining was of course more from the geology point of view. But there are many other departments where, for example, we have the agrometeorology. We have the meteorology only for civil aviation. So civil aviation department has to be convinced. So you have to convince, so there were 14 secretaries, including the planning commission. And planning commission secretary was Mr. Rajiv Ratan Shah. He was a very senior IAS officer, next to the only cabinet secretary. And, but luckily, I had the background space, so I had worked with Rajiv Ratan Shah and also B.K. Chaturvedi because they were all members of the Space Commission. But he said one thing, if one of these 14 secretaries says no, you will not get your Ministry of Earth Science. That means you have to convince, I have to convince all these 14 secretaries that yes, the country needs this kind of creation. So with all that happened, we had sold only one thought to them, that if you are looking for a consideration is mostly for the society. And I always quoted this particular sentence, which Professor Sarabhai used in 1967 in a conference in UN. And he was quoting in the context of the space. Because at that time in 1967, when we gave the idea of creating a space in India, a space department, or you can say ISRO basically, not department came much later. He has said that our purpose is not really going for, let's say, exploring outside atmosphere or going to planets and all that. But we are convinced that if India has to play a role in the society of nations, that we must be second to none in utilization of the advanced technology for men and society. Men is a plural there, it doesn't mean only men, also includes women. So, but that word, man and society, remain a Bible for us in ISRO, and also for me in all my life, that ultimately you have to serve. So when we created this, there are two aspects. We were creating not the only Ministry of Earth Science, because it's not for science alone. It's a mission mode ministry. And when it's a mission mode, at that time, there are only two departments which have been created in mission mode. One is atomic energy, other is space. In fact, there was a mission mode department created somewhere in the mid-70s, Department of Electronics. It used to have a electronics commission. But in some process, I'm not getting with the detail later because that will be digression. The department was closed, not department, so the commission was closed, and we never got a commission later. And we lagged in electronics partly because that happened. So here we were very keen that we have to create a ministry which is a mission mode ministry. And that's something I thought I just mentioned to you. the driver for creating the Ministry of Earth Science was that ultimately Earth Sciences should be for man and society. So we do the science, but in addition to the science, the application part, and in that context, when we are sitting in inquiries, that becomes very relevant. Because inquiries is a so-called servicing unit or servicing center of the Ministry of Earth Science, which actually provides the service to the people. When you say there are two things. One is inquiries and Oceanside IMD. All other centers are their research institution. They are really enabling the service. They are enablers. So this is something which we really need to keep in mind. And of course, in all sense, the tsunami of 26th December, that was also there in our mind. Because that was a time when we lost, I don't remember exact number, tsunami, remember, I think 30,000 or 40,000 people we lost in that process. It was a huge loss. So that was also behind it. And I just want to mention that because the moment I took over, that was the priority number was actually tsunami warning system. Even the creating ministry was the priority number 2. And that's why I requested Dr. Shailesh Nayak to come from SAC. He was my colleague in the space. So in fact, when Radha Krishnan left here, I really requested Shailesh to come here. Because the service part and tsunami part was very important. And of course, later is the history that we have one of the best, you can say, tsunami warning system in the world when we created. And you know what gives me pride? I just thought maybe a little digression here, that one psychology of Indians is that if you make a statement and it doesn't happen to be correct twice, third time they don't believe you. And particularly when you are asking people to vacate their house, it's a very difficult situation because they are poor people. The people who live at the coast, they are not rich people, they are very poor people. And you ask them to vacate, maybe they will do it once, they will do it second time, third time, whatever you do, they will not do that. So our main slogan was that we should not give a false alarm. And in what background? Background is Japan. Japan, out of 10, 9 will be false alarm. They give a false alarm, they say tsunami will come, they will vacate, but there this is accepted. They vacate, they come back. In India, if you do that, they will not believe you. It becomes a full story. So I'm proud to say that after so many years, from 2005 to nearing 2 decades, inquiries has not given a false alarm. There's something very credible. At that time, just want to tell you, there was a lot of discussion about inclusion of NIO, because NIO is basically ocean. And in fact, I can tell you today, because it's history, that it just almost happened. Actually, the cabinet secretary, I made a cabinet secretary write a note about inclusion of NIO in Ministry of Earth Science. I gave a paper that NIO these are the things that should happen with a recommendation from the minister. And the paper went. It just happened that day also the meeting with the Minister of the Four Secretaries, and somehow our Minister Principal, by slip of his tongue, he mentioned to that time DGCSIR, Dr. Mashelkar, that he just asked, okay, you have sent the paper about NIO? I said, yes, sir, it has gone, Cabinet Secretary. And Mashelkar, being alert scientist, he said, what is the paper is? Then he had to say, yes, this paper is about transfer of NIO to the Ministry of Earth Science. And he just made such a huge hue and cry that the minister had to request me to again, sir, you please go to the Cabinet Secretary and take the paper back. If that had not happened for next 2 days, we would have heard the NIO be part of Ministry of Earth Science. Anyway, there's a history, but I thought that we can discuss those things, though we couldn't discuss in those days. Similarly, there was a lot of discussion about whether GSI or the marine part of GSI at least, the marine division, that should be part of Ministry of Earth Science. But the problem was, we had a very small headquarter dealing with DOD. And as I said, total strength was less than 200 at the scientist level. So we were actually bringing huge IMD with his all baggage. And that is actually altogether a separate story. That huge baggage in the sense that big system, which is, has totally fossilized. In fact, IMD was living in the year 2005 in an era of 1970. They had not come up for 35 years. They were actually behind 35 years in terms of every aspect of the technology, every aspect of science. To bring them up, so it was suggested that bringing full GSI, which is another more than 6,000 people, will be impossible to manage. But then there's another issue, and today we can discuss in the thing that the Ministry of Mines would have never agreed. And as I said, the Cabinet Secretary told me that if one secretary doesn't agree, we will not have Ministry of Earth Science. So I thought, let me have my ministry and not worry about the GSI part of it. So that's how GSI remained. Another problem. As I said, this problem we can discuss today because it's the past, but not in those times. Professor Ramamurthy, Secretary Department of Science and Technology. He was a good friend of mine. I've done a lot of work together in space, so we were very good friends. Even today we are very good friends. So when I told him that we have to make this ministry, he said, Goel, thought is good, but do you think I'm a useless fellow? I said, sir, I never meant that. He said, I am secretary of this department, where IMD, IITM, and NCM are a part of my system. And you say they are not doing anything, useless, and I am secretary for last 10 years. So what reflects on me? So I said, sir, I don't mean that, but we need to do this. Finally, he said, yes, I agree with you. And this I'm talking about 2006, January, February, where everything else was ready. Cabinet road was, everything was ready. But I have to get signature from him. So he said, I'll not sign till I'm retiring. So he said, I'm retiring on 31st May. I'm not against it. He also told me, I'm not against it, but I don't want to prove myself that I'm useless. So he said, you make your ministry after this, after 1st of June. Till that time, I'll not sign. So I talked to the minister, he said, yeah, let this man go and then we'll do that. So that's how the ministry formation got delayed by almost 6 months. So all these things happen. So I just want to tell you that in this, there were a lot of people who really helped also. And particularly I would recall Rajiv Ratan Shah. He was very positive in convincing other people also. And also there was a expenditure secretary, all these people have been. So we got the approval from July 12th, 2006. In fact, when we always celebrate in the Department of Ocean Development 27th July as the Foundation Day. Now the question came, what do we do? Whether we celebrate Foundation Day on July 12th, because that is the day this ministry came into existence, or 27th July. But then it was a conscious decision because the ocean people, all of you are very emotional people. Like IMD is attached, they are also, say IMD called India Metallurgy Department. And no more department. In fact, I wanted to name it India Metallurgy Agency. But, at least 200 people gathered. Sir, we are a department from like 1975. Sorry, 1875, 150 years. So one of the oldest department of the government of India in British time. The oldest is Survey of India. The next department the country had was the IMD. So he said, well, we don't want to lose our history. Similarly, the ocean people also, they don't want to lose their identity. So I said, doesn't matter. We'll consider 27th July as our Foundation Day. So these things happen, but something. But then there was a big transformation in our system. And I just want to mention that very enormous support from Government and Planning Commission. And that is shown just by the fact that our budget from 11, 20, 25 crores, it went to 7,500 crores, a 5-year budget. So it's a big system. Now we have done a lot of successes now. Tsunami warning system is set up, which is something very important. Other thing happened was in the part of tsunami warning system, we became a center of the monitoring of the earthquake. And in that setup, there also a lot of emphasis came from the government. We should work on the forecast of the earthquake. In fact, I spent a lot of my time in running whether earthquake can be forecast at all. It's a separate story, I'm not getting to that, but it's something area which we really continue to work. And when it comes to support from the government, in the whole life of the atomic energy or space, starting from 60s, there never has been a meeting of the commission, those commissions, the Prime Minister office. But the Earth Commission, after 4 of our meetings, 2 happened in the Prime Minister office. So we had a lot of goodwill and support. But when it comes to where we have to focus, I'm just listed these things, I'm not going to talk on that, but there are the areas where there's the water desalination, Dodo Boys, a lot of good work we did on the continental shelf and in terms of claiming our areas. So all these things have happened. I'm not really getting into too much details. Similarly, when it comes to forecast of the weather, this was an issue which has really taken a lot of, you can call it a change of mindset. As I said, Mr. Bhukal Lal, the DGIMD, said he will not really touch the numerical modeling. So changing that mindset. Once I was discussing with them about the so-called instrumentation, and Bhukal Lal said, I have got the best laboratory in IMD. So when I went to look at it, it was worse than any BE engineering college. Then he said, no, sir, this is nothing. I'll take you to Pune. And I went to Pune. Pune Instrumentation Lab did not have a good oscilloscope. So I'm just trying to say that what kind of a world they were living. It was they're living their own shell. And then when it comes to what IITM does, IITM is supposed to be the research laboratory for the IMD. And for that purpose, someone in a very good thinking had decided that the governing body chairman of the IMD will be the DGIMD, governing body chairman of IITM. I don't know how the system was working, but not a single technology in last 40 years had come from IITM to IMD. They were just totally isolated. Similarly, there was absolutely communication block between IMD and NCMRW. In fact, whatever NCMRW, they were trying to compete with IMD and trying to put them, okay, these fellows don't know nothing. So there was absolutely kind of this thing was happening. In fact, once I was discussing again with Dr. Ramurthy in this context. He said, yeah, what do I do? I have not spent even 10 hours in my 10 years of life with IMD. So that's the kind of attention they were getting. IMD per se had learned a lot of good work, but that was not really flowing into our services. There are many things which are very badly organized, and one of them is the agrometeorology. We had the divisions, both in NCMRW and IMD, but there was absolutely no reach to the farmers. So I requested Dr. From Rathore, to take over in IMD. And in fact, first they said they would not accept him because he came from IMD earlier, and they say he's coming at with 2 grades higher. He got a promotion. So all these problems came. But another thing, one day our Deputy Director General, he retired. So I have to get a new Deputy General. So it has to come only from UPSC. So I went to UPSC. Then the next person was someone who had done nothing. I won't name here now. He had done nothing in his life. All the time talking, and actually there was nothing to. So when I told the UPSC chairman that, look, I don't want this person, next person is much better. He said, sir, doesn't reflect in your CRs. We look at 5 years CR. If there's no adverse remark, the next person gets it. So merit and all that is your problem. You should give, if you don't want a person, you give adverse remark. Now, in science and technology, I have not heard anyone who is giving adverse remark. We'll say maximum that, okay, he's not the best, he's number 2, he's very good. I don't think anyone gets less than very good. So the next meeting, within next month, I just took out Ministry of Earth Science out of the UPSC. So today you don't have to go to UPSC. So these are the kind of changes we have really made. The point is, there are a lot now that has happened, that from a very unscientific department, the Ministry of Earth Science has been made probably at par with any scientific department like ISRO and atomic energy. And having done that, now the focus has to go back to the man in society, and we have to talk about, you can say, to the services. There are many things which really have gone understanding. Again, that's something which I would like to focus something on others later. What we have done today as a part of mission mode. When I talk of 2005, there was saying in Delhi that if IMD says it will rain today, don't take umbrella. Today, if IMD says it's rained in the evening, you better take umbrella. So we have made that perception change. And I think the forming Ministry of Science has make a big role in that. We have really created a big infrastructure, even though it's not sufficient. In fact, when I organize a study, what kind of a radars we should have, Doppler weather radar. And so a study came that we should have totally 55 Doppler weather radar as soon as possible. In fact, that was a part of, I think we have now, around 40 we have now. I don't have the exact number. So we have not, but we are reaching towards that. So there's a tremendous push towards the infrastructure. Similarly, all other observation systems. I just wanted to know how the inset images of the VHR are being used. In fact, I remember I was a member of the configuration of the INSET-1 in 1977 or 76. And I was told that at that time, that there is no INSET without VHRR, very high resolution radiometer for the IMD. And when I came here in 2005, I asked how you are using the data. I discovered rather, no one told me, the data was being used that either you put in the, when you go to visit someone, you give a good picture and he puts in the cover on the table to show the pictures are. It was never being assimilated into the weather forecast till 2005. Now, of course, there's a lot of change. So ultimately, and when you really look at future, see, you're talking of modeling, you are talking of modeling at different scales. You really need to have the data. And you can't have ocean data from the observations except that's from tsunami buoys, but that will be very sparse. You have to ultimately use space. You have to develop technology to really space data, whether it's from the various kind of instruments you have. Okay, so yeah, the services like you are running here, PFZ or border surveillance, all these things, we have to really get into a mode where people should really feel that Ministry of Earth Science is part of our life. See, I always used to say when I was in space that our aim is to reach the goal of Sarabhai, that a man should feel. And today, all of you carry mobile in your phone. you know location. It comes from satellites, space. There are so many applications of the space, I mean, whether it's communication, whether it's remote sensing. Similarly, the services coming from Earth science should be part of people's, you can say, day-to-day life. If someone is looking at weather every day, it comes from the Ministry of Earth Science, the data, information. So that people should start depending on us. The ultimate goal is that people start feeling, yeah, this Earth science is making a difference to our life. And that will be whether it's agrometeorology or whether it's earthquake information or any of these things, services is something which we need to worry about it. So, okay, I'm not getting into the details now. So what I'm trying to say is that we have well done. We have very significantly improved the weather forecast. Whether our cyclone warning particularly, its track or its what is kind of intensity, magnitude, all that we have done very well. We are also to do something about earthquake, if not forecast, at least how to make buildings. If something is happening in Himachal Pradesh, the buildings are falling. I think every one of you or every one of us has to feel that if a building falls, there's some role I have to also play. It's another part you will feel that, okay, why I should feel something happening in Shimla. I have one example to give you, which this just comes to my mind. Somewhere in 1998, Professor Satish Dhawan, later he was a tall figure for me, he was much senior, but once in a while, when I was director, he used to come. So one day he came and he was very upset. And upset in the sense that he felt that nothing is happening, we are not doing anything. So he started telling, look, around that time there were 2 or 3 railway accidents. And he said, he told me directly, well, you're not doing anything. So I said, sir, I'm making satellites. What I can do about railway accidents? Then he said, are you not Indian? And I really remained upset for quite some time that my mentor, whom I treat as a god, was upset with me because I'm not doing anything about railway accidents. It didn't occur to me, and it's much, much later I realized that the pain he was feeling as a scientist, the railway accidents happening, it's not whether you work on railway or not. And of course, today, at least you know, all of you know, that we have a system in every train which actually works on accident avoidance, in fact, collision avoidance. A component has come. But nevertheless, it doesn't matter whether we have put from space that kind of technology or not. The moment you feel part of the system, your attitude towards your life changes. And that's where I would say that Professor Dhawan had achieved that state of mind. That if anywhere something happens, he was feeling pain of it. And that's something very important. So in that context, there are a lot of good things happen. But actually, quite a lot have to change. For example, we still not use the satellite data, meteorology data. We have not assimilated fully into the weather models. We are still not having sufficient, let's say, involvement, data assimilation of radio, sound, radar, wind profiles into the models. Radars, weather radars, we still don't have a good system in the hilly regions. We have to make a lot of progress in deep ocean outreach. In fact, Dr. Srinivas Kumar was briefing me about our gliders. We need to have a lot more information of the ocean. We really have to serve the country. We have some good examples of coastal protection systems. if you really see Pondicherry, and even if you go today, you have a look at that place. You'll find along the Pondicherry coast, you'll find a beach almost a few hundred meters. If you go 5 years back, the sea had come completely to the beach. So intervention by our group in NIOT, by Ramana Murthy's group, we have really saved that big intervention. So some good examples are there, but they are examples. Example does not mean we are serving the country. I can make one research in a plant, do a good example, but does it mean I'm serving the coastal region for that? So there's a lot of difference between technology demonstration and technology serving the people. That gap still exists. So we need to fill up those gaps in many areas. Actually, our interventions in terms of technology development, we have done many. But technology penetration to the society, we have a lot of lacking. I hope that so-called Deep Ocean Mission will try to bridge this gap. So I'm just trying to conclude this part here. And when I was talking to Srinivas Kumar, he just said that that you'd like to have something about the Chandrayaan. I didn't collect one picture, but I just thought I'll just brief you. And I'll not tell you what you are hearing about in the TV. First, let me just explain, because I understand all of you are scientists. What is critical in Chandrayaan? How is different than, let's say, launching a satellite in communications, launching a satellite for meteorology or remote sensing? When you launch a satellite for meteorology, I have an orbit, I have to achieve that orbit. If it's 10 kilometers this way or that way, I correct it. It's not an issue. So I have to have a launch capability, which is anyway existing with us, and we have done that. But when I talk of a landing on moon, actually I have to start reverse. We decided that we will land on the southern part of the moon. Why southern pole? Because that is unexplored. Because whatever the processes that take place, even in vacuum, suppose I have got a vacuum of -3 or -4, even in that the water has got its own motion. And where water will go? It will go to a cooler place. Actually, if you really put a glass of water with ice, on the glass you will have water deposited on the outside. That's because the water from the atmosphere comes in a cooler place and condenses it. So where it will condense? It will come to a cooler place. So because the poles are cooler on moon, so if water had been there, where will be maximum? It will be on the polar region. So you want to explore polar region more. One is water, because if you are talking of a human sustainability at all in time, maybe 10 years, maybe 100 years, it will be more sustainable because of the important is that water is available for sustaining the life. So we decided that we will be different from others. But then the moment you go to southern pole, your light is less. So you have to worry about how do you get enough power. There's a design of engineering. I'm not getting engineering right now, I'm not getting mission now. So we have located a location that we should really go to the south. Then south, when do we start? We start on the, when the day starts. Now for moon, it's 28 days, 28 days, 1 day for moon. So that means 14 days is a day and other 14 days is a night. So if I have to get power on the southern pole, I need to start just when the day starts. So my location is fixed and my time is fixed. So I have to start backward. Now depending on my launch capability, I have to start, suppose I have to have a 4 orbits, increase the orbit here and there, decrease there. So all that I'll start, so I'll get a mission. So first part is a complete mission planning. So I've done a mission planning. Now where is the question of complexity comes? Complexity comes in terms of sensitivity. See, you are traveling at a velocities of or the order of when you start orbiting, I have a velocity of something like 10.4 kilometers per second when I inject the satellite. And when I go on increasing velocity, it goes to the extent of something like 12.5 to 13 kilometers per second. And when I go at the apogee, my apogee should come that when I have the further distance, the moon should be in that plane. So that means I have to do the back calculation that when I do the fifth correction, at that apogee, moon should be in that line. And in that line, I have to again fire because I have to escape the Earth's velocity, Earth's gravity, and get on the moon's gravity. Now, in that transition, which we call TLI, translunar lunar injection, that time I have to really correct to the same plane because that place I have chosen as a launching, as a landing point, that should be in the orbital plane of the moon. So here, if I am slightly off, I'll miss my location. So there, the accuracy of your velocity control in terms of velocity as well as the direction has to be very, very, my precision of the angle has to be less than 0.1 degree. And my velocity control has to be something like 5 meters per second. So when I'm giving a velocity of something like 5 kilometers per second, and that my accuracy has to be 5 meters per second. So you are looking for very precise numbers. And there you do not have GPS. You have to calculate the orbit only from the other techniques like Doppler. So you're measuring of that, understanding the orbit every time. And if I make a 1 meter per second mistake, if I don't correct it in the next correction, then that will grow. So the real problem lies, or real technology lies, in your accuracy of the numbers. In fact, when I was working on Chandrayaan-1, when I was director there, we had a meeting with Russians. And that time, it was somewhere around 2001 or 2002. They said, look, what are you doing? You cannot achieve that. And they said, we lost 3 missions. They didn't announce to anyone. They said, we lost 3 missions. The so-called spacecraft, it escaped the Earth, but didn't come to the capture of the moon. So everyone had got into the problem. But of course, luckily, that time the computers were not sophisticated. Today, the computers whatever could be done in a big computer today, I can do in a small board. So we have got advantage of technology today, that's certainly there. Similarly, star sensors. They were not that accurate in those days because there was no CCD, or CCD was also very coarse. Today, I have got a CCD which has got something like 10,000 by 10,000 pixel. So that gives me a much better sensor accuracy. In fact, today I can get a star sensor with an accuracy of 1 arcsecond. That was not available. But still, the requirement of accuracy, your control on the thrust is so accurately required. Because if I don't do that, so this is one part. So mission planning and then achieving the direction of your thrust or direction of your control. Both are important, and both are important to very high accuracy. Now, having achieved that, the last part is again very critical, and that is the landing. And what is involved in landing? For example, this we are achieving in 4 phases. You assume that when my last orbit is approximately 30 kilometer near circular orbit of the moon. Now, moon gravity is very complex. Some of you may be thinking how gravity can be complex, but those who work on gravity model on the science, they understand that. So for example, on Earth, because of obturateness, we have got a large J2 component. Moon, because it's got a lot of cavities, a lot of, you can say, uneven surfaces, the densities are different. They have got multiple of that effect. But luckily, that has been very well modeled by Americans. So we had the advantage of the gravity model availability from Americans. That advantage we had. But with that, we have got a 30 kilometer, near 30 kilometer circular orbit. So this is where your first point is. Now, There the velocity is about 1.6 kilometer per second. So with that velocity we are starting. And when you want to land, actually when the trajectory goes down, you have to really orient your thruster exactly opposite direction. So when you see the trajectory in the first phase here, your thruster has to be completely oriented, reverse the velocity. So that part was achieved. But that is simple. Then you come to the level of something like 7.5 kilometer. So from 35 kilometer, 30 kilometer, you went to 75 kilometer. There so first phase we are calling it rough braking. Now here we call it little kind of fine braking. So you are further braking this velocity, and here you are trying to achieve more accurately, and from there, this more accurately means I have to have a precise thrust control. What it means, so you might have seen the rocket motor. Most of the rocket motor, when you see, there is no control of the thrust itself. There is direction control. But here I have to control the thrust level. And so when thrust level happens, so you are really achieving 800. Now 800 meters have come. But at this stage, 800 meters, actually now I have to really see, I have to reach that point. Now in that process, you might have been, in terms of horizontally, you might be 1 kilometer or 2 kilometers this way or that way. So now you have to really get to this, what you call is in a launch vehicle or satellite terminology, closed loop guidance. That means continuously I have to really orient my orientation as well as the thrust level. So both have to be controlled. And this algorithm is called closed loop guidance, and we want to achieve with that something like we want to go to 150 meters. Now when I've got 150 meters, now I'm practically vertically looking at it. Here, if I land and there is a crater or there is a slope is more than, let's say, 10 degree, then when I land, how do I control the velocity, horizontal velocity? So far, we are depending only on inertial sensing. Inertial sensing essentially contains gyroscopes. So we have got a very precise gyroscopes even though, but then this was calibrated when I started my rough landing. So that means from that time and onwards, when my velocity was 1.6 kilometers and when I'm coming to, so even a small error, I will land up with 2 meter, 3 meter. But if I've got a 3 meter error in the measurement, but particularly translation velocity, if I land and the 3 meter, it'll topple. So that means I have to control the velocity very accurately. How can I control? So I'm can see only on the ground and see the ground motion, the up, and you see the ground. So I have to compare the images. And from the images, I have to compare the velocity. Otherwise, I'll not get the absolute result. So now it comes that I'm really trying to look at. Also, there is an avoidance of a, whether there's a big stone or whether there's a big crater, all that has to be avoided. And if the direction, if the slope is more than 10 degree, it's very likely even with 1 meter per second lateral velocity, I'll topple. So our aim is not to let this, if the lander topples, then I won't have the rover out. So the precision lies in that I should have practically within 1 meter per second horizontal velocity, and the velocity coming down also. We can tolerate up to a maximum of 3 meters per second, because I'm falling down. If it's more than 3 meters per second, then the lag may break. So we have to have the vertical velocity also less than 3 meters per second. So essentially, what lies is that our ability to control velocity, our ability to avoid craters, our ability to provide slope. In fact, we pre-select only because the area where we can get at least 1 kilometer, where the slope is proper. But there also can be boulders. So boulder has to be avoided. So all this is part of our, you can say, onboard algorithm. And nothing can be done man in loop. You cannot see and do it. Everything has to be done by the autonomously only by the lander. So all this algorithm which I explained to you, they have to be within the, actually frankly speaking, about 200 people are sitting there. We do nothing. We only watch. Everything is actually preloaded before the rough breaking starts. Other than watching, there is absolutely no role for a human being. So we are all watching, whether it's a chairman or whether it's an operator, whether it's a mission person, everyone only watches. So when you see, you will find absolute silence, means everyone is only watching what they are doing. Whether proper system is working all right. Proper system follow only monitors, okay, there's a propellant flow, there's a gas flow and all, he just monitors, but he can't do anything. So for doing this, nothing, everything has to be pre-planned and all the algorithms has to work together. So this is the part of complex. So I thought I'll just mention to you, with this, I think I already exceeded a few minutes, and, but if you have any questions either on any of these issues, I'll be happy to answer, depending on the timing permits by the organizers. Thank you very much. Jai Hind and Vande Mataram.
Sir, had NIO joined MoES those days, do you think the scenario could have been different today?
Pardon?
Had NIO joined MoES those days, had the scenario could have been different today in oceanography community in India?
See, I don't answer speculations.
And my second question is, you are such an eminent personality, you could convince 14 secretaries those days, but how could you not able to convince Mashelkar?
How could I not?
Able to convince Mashelkar to join NIO into MoES?
See, I think there is one weakness in human being. We all have our own preconceived notions, and we all have our own, I would say, in mind, okay, I'm doing best and all that. So these things happen anyway. Convincing, it was so easy, the word would be very different. The most difficult part is ego. So these are things in life. What works in, you can say, science doesn't work in society and doesn't work anyway in politics. So it's not that easy. In fact, I can tell you that we could create the Ministry of Science in 2005. It will not be possible in 2023. If someone asks me to go back and do it today, it won't be possible for various reasons.
Please. I have been hearing talks maybe for the last almost 50, 60 years. I am 82 now. I never heard a talk like this with a vision, because all the talks I heard were extreme, either science or technology. The type of the vision you said is extremely rare and fantastic. I am really excited to hear your talk. It is really combines both the science, technology, and the human aspect also, because that's exactly the IMD inquiries they are doing. It's really, I never heard for the last maybe 50, 60 years a talk like that. Now I have probably you are the proper person to answer this question. Ministry of Earth Sciences. After all, this ministry is a science department. One of the complications, as I see, as a scientist, he never bothers about the service, human service. For example, in our hardcore meteorological science, the real discovery of the Rossby waves, the baroclinic instability by Professor Charney of MIT. When Professor Charney discovered baroclinic instability, I don't think he thought about the service or anything, because the hardcore scientists, they work, they discover for the pleasure of the discovery, not for the human service or anything. So how a man like you, I think you are the correct person to tell me about how to coordinate these two. The science aspect, as a scientist who never bothers about human service, On the other hand, after all, the money comes from the taxpayer, so we have to do some service. Okay, but anyway, hats off to you. Really wonderful. I never heard a talk. I'm 82, I'm saying. Wonderful. Congratulations or whatever you say. Namaste. Sir.
See, I think I was lucky to be associated with some people. See, I had very little association with Professor Sarabhai. I met him as a person only once. And that too, just a day before his death. Professor U.R. Rao, he brought to our lab and we shook hand and just exchanged a few words. But I have heard him quite a lot of things. But as a person, I met him. But I have read about him a lot. And when I understood Sarabhai, he's a very different kind of person. He's a mix of scientist and businessman and service together. There are so many stories, actually I can take one full lecture on about Sarabhai alone, but that's not the purpose. I'm just trying to say that I was lucky to have so much knowledge about him. Professor Dhawan, I had much more association. And he was a scientist come manager, but later, in fact, I seen the transformation of Professor Dhawan himself. Till his retirement in 1984, he was more of a manager. Before that, he was, of course, scientist, but in the last 12 years of in ISRO, he was purely a manager. I don't think he did any science himself, but he was a manager. But later, he became much more of a philosopher. So I have seen that turning. I gave you the example of railway accident. See, why a person who is working on aerospace should worry about the railway accidents? Is that the humanity part, a transformation himself. And you see all the people, great people, they always, you see Mahatma Gandhi. From a barrister, just because he was thrown out of the train, he became a independence fighter. But then later stage, he became much more a different person. So we all evolve. So I have seen the evolution of Professor Sarabhai and Professor Dhawan. And to start with, I started the control system of satellites. I was doing nothing else. If I take my career from 1970 onwards, till approximately, let's say about 20 years, I was purely a control system person. Then only I get into rockets or got into satellites to the. But later, because of the association, this word of Sarabhai, that advanced technology for man and society, didn't remain a word alone. They became a kind of a, you can say, belief. There is a difference between a message and a belief. So for me, so when I came here, the ministers as a secretary DOD, as I said, I am first person to admit I had absolutely no idea about ocean. I have absolutely no idea of atmospheric sciences. I learned only by talking to a question. If I ask Shania something, he will tell me something. I'll just give you an example. I can tell you all of your ocean people. I'll ask you a question. And let me tell you how many you can answer. Which actually, I had a question. And at that time, I asked at least 20 people. No one could answer that. And let me see how many answer. Basic physics. You see ocean surface. Suppose ocean is 2 kilometers deep. Ocean surface, the temperature at that place is around 2 or 3 degrees Celsius. Agree? Agree or not? Agreed, no? Okay. You go up, temperature will go up, come to the surface will be 28, 29, correct? You dig, let's say 10 meters down, temperature will go up or not? It will go up. It goes up, okay? It goes up steeply. So now you go up, temperature goes down. Now you are at 2 kilometer depth at the surface. You go up, temperature up more. You go down, temperature down, again up. How can low temperature can remain there for thousands of years? Above you go, temperature is high. Below you go, temperature high. But at that surface, temperature is low. How can that happen? How many can answer? Raise hand. How many of you can answer this question? Raise hands.
Yeah, but I am a meteorologist by training, and I learned
No,
long.
sir,
Yeah.
welcome to sir. This question, you are all ocean people. How many of you know the answer?
But I
No, you know or not, don't try. I tell you, I asked at least so many people, and only one poor person could answer me after 1 year. So, question is my only strength is I want to know. I have anxiety which you people don't have. You have worked for so much time, but you never thought of it. So you have to, if you want to do something, you have to ask why. That's all. Thank you.
Thanks a lot, sir.
Hello, sir.
Yeah.
Sir, I had a question from here.
Can we discuss over tea? Yeah?
Okay, sir. Okay.
Okay, thank you. Let us now take this moment to appreciate the guest of the morning. I request Dr. T. Srinivas Kumar, our director, to kindly felicitate Dr. P.S. Goel. Thank you, sir. As we draw the curtains on this engaging and enlightening session, I have the honor to deliver the vote of thanks on behalf of the organizing committee. First and foremost, my sincere thanks to Dr. P.S. Goel for sharing his invaluable insights through the plenary talk. Thanks a lot, sir. It was wonderful knowing the history and beautiful journey of MoES. And also a big thank you for leaving us awe-filled by sharing some of the facts behind Chandrayaan mission. Special thanks to Patabi sir for his unwavering dedication and leadership. I also extend my gratitude to our dear director, Dr. Srinivas Kumar, who helped us shape this event. It is through the combined efforts of the organizing committee that this session has come to fruition. We are extremely thankful to you. I also extend my gratitude to all of you participants, guests. Thank you all. We shall continue the interactions during the evening valedictory session. I request you to join for high tea, the ground floor. Thank you.